Hello everyone, hope you all are doing good. I am Anjana from Learnohub, the free learning platform where you can study math, science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 9 Physics Chapter 6 Heat and Energy. We will be discussing the topic heat and temperature and also anomalous expansion. Are you ready for the session? Let's begin. What is heat? How is heat produced? To understand this, we can do a simple experiment. Just hold your hands in this way and keep rubbing the palms against each other. Okay. After some time, what do you feel? So in cold climate, okay, in winter season, you do these things, right? So you will be rubbing your hands and you will keep it here. You will be feeling hot. Okay. Why is it happening? This is because heat is produced in your hands. Okay. Now, a metallic wire. You can see the wire is connected to a battery and there is a bulb. Okay. After some time, so here current will be flowing. So, with the help of this battery, current will be flowing which helps to light the lamp. Okay. So, here after some time, you will be able to see that the wire will start getting heated up. Okay. The bulb will start getting heated up. So, what is happening here? There is a conversion of energy. So, in this case, when you rub, what energy is there? There we are doing work. Okay, so energy is because of the work, which means here mechanical energy is involved. This mechanical energy gets converted into heat energy. Okay, mechanical energy is getting converted into heat energy. Now the second case. So here there is electricity, which means here electrical energy is getting converted to light the lamp. There is light energy, but the lamp is getting, or the bulb is getting heated up, which means there is heat energy also involved. Okay, electrical energy getting converted to heat energy. What about this case? Burning a coal. So when you burn a coal, what is happening? You can feel heat, right? Okay, so heat energy is produced. From where is heat energy produced? So we know energy can neither be created nor be destroyed, but can only be transformed from one form to another. This is law of conservation of energy. So where do we get this heat energy? So when you burn a coal, there is chemical energy. So here chemical energy is getting converted into heat energy. Okay, so this is how heat is produced in different instances. Okay, we'll be discussing many more examples. So we can define heat. Heat is nothing but it is a form of energy. Like other forms, mechanical energy, sound energy, light energy, chemical energy, heat is also a form of energy which we call heat energy. And it is transferred between two bodies at two different temperatures when kept in contact. Okay, when you have a hot body and a cold body. Okay, what happens? For example, you are taking hot water in a glass. Okay, half of the glass is filled with hot water. You have another glass which is filled with cold water. Okay, when you transfer some cold water to the first glass that is containing hot water, what happens to the temperature of the glass? What happens? So here the temperature will decrease, right? When the hot water, when you add cold water, the temperature is decreasing. That is, hot body will start cooling down. Okay. Now to the glass of cold water, if you are adding hot water, what will happen? The temperature of the glass, okay, the temperature of the water inside the glass will start increasing. That is, a cold water, temperature will increase. Okay. So here what happens is there is a flow of energy. Okay, heat is a form of energy and it is flowing. From where to where? It is from a hot body to a cold body. This is how there is transfer. Now when you consider any object, inside the object there are molecules. Okay, solid, liquid or gas. We have discussed all these. So if you have solid, liquid and gas, we know that inside the solid the particles are closely packed. In liquid, there are spaces. In case of gases, the molecules are loosely packed. Okay. So in all these cases, there are molecules. So what you can say is these molecules will possess some energy. Okay, so you can see that when you start boiling water, what happens? You can see the particles of the H2O molecules, okay, they will start vibrating. Okay, that is, they are gaining energy. This energy possessed by molecules we call internal energy. Okay, they possess internal energy. Okay, these molecules possess internal energy. Clear? So, this energy starts flowing from a hot body to a cold body. This is what happening. Okay, so remember this thing, the energy flow direction is from hot body to cold body. Okay, so when you have two bodies, okay, they are kept in contact. So, they will reach an equilibrium when both the bodies are at the same temperature. That is, from the hot body, heat starts flowing to the cold body, the temperature of the cold body starts increasing. Once they reach equilibrium, that is, both the bodies are at the same temperature, there will be further no heat flow. Clear? So, understood the concept? What happens when you touch a hot body? Have you ever touched a hot body? Have you touched the iron box or a pan which was kept on the stove for some time? So, you can feel heat, or simply if you touch hot water, you can feel the heat. So, here what is happening is, from the hot body, the heat is flowing to the cold body. So, here, which is a cold body? Comparing to hot water, our body is cold. Okay. So, we are able to feel the heat because there is a transfer of heat from the hot body to a cold body. Now, when you touch ice, what happens when you touch ice? So, here when you touch ice, is there heat flow from the ice to your body? No, right? So, when you compare with the ice, the temperature of our body is greater than the temperature of ice. Okay, which means heat energy will now flow from body to the ice. Okay, heat energy will now flow from the body to the ice. So, we will be feeling cold and not hot. Okay, on touching a body appears hot to us when heat energy flows from that body to our hands. Okay, while it appears cold to us when heat energy flows from our hand to the body. Got it? Now a question, why do you feel hot when you touch an iron chair placed in sunlight? It's not necessary that you place iron chair itself, even the plastic chair, when it is kept in sunlight for some time and you go sit on it, what happens? You will feel the heat, right? So here what is happening? From the iron chair or the plastic chair, from the iron chair, the heat is transferring to your body. Okay, heat energy is getting transferred to your body. This is why you will be feeling that hotness. Okay. Now, why do you feel cold when you touch an ice cube? This we have already said. When you touch an ice cube, what happens? There is a heat transfer. Okay. From where to where? So, here from the finger which is at high temperature and ice cube which is at low temperature. Okay. So, from a body, there should be a difference of temperature. For heat to flow, there should be one condition. One important condition is there should be a difference in the temperatures of the body is considered. Okay, then the heat will flow from a body which is at high temperature to a body at low temperature. So, here you can see finger is at high temperature and ice cube is at low temperature. So, you will feel cold because here there is a loss of heat from your body. Okay, so these are some examples. Now, what is the unit of heat? We have said heat is a form of energy. Okay, what is the unit of energy? Energy's unit is joule. Unit of work, unit of energy are joule. Okay, while writing joule, when you write the unit, you have to put small letter j and not capital letter j. Capital letter j means it is not the unit, it is a name of the scientist and it is represented by capital J. Okay, so joule is the SI unit, simple system international unit of energy. Okay, then there is a CGS unit. What is CGS? In CGS unit, the length will be in centimeters, mass will be in grams and time will be in seconds. So, this is a CGS unit. CGS unit of heat is erg. Okay. So, 1 joule, the relation between joule and erg, 1 joule will be equal to 10 raised to 7 erg. Okay. There are other common units. Other common units are calorie and kilocalorie. So, what is 1 calorie? 1 kilocalorie will be equal to 1000 calories. We know kilo means 10 raised to 3. Okay, 1 kilocalorie is equal to 1000 calories. This is the relation between kilocalorie and calorie. 1 kilocalorie equal to 1000 calorie. Okay, now what is the relation between calories and joules? Okay, the relation is 1 calorie is equal to 4.182 joules, or approximately 1 calorie is equal to 4.2 joules. Okay, so these are the common units of heat. Concept of temperature. What is temperature? So we know that thermometer is a device that is used to measure temperature. Okay, so when you have fever, what is happening? There is a rise in your temperature. So the normal room temperature is 27 degrees Celsius. Okay, so here when you go to doctor, the thermometer is kept under your arms and the temperature is checked. There will be some increase in temperature. Okay, so how is it measured? Using a thermometer, we can measure the temperature. Now, what is temperature? In simple words, you can define temperature. It is a measure of the degree of hotness or coldness of the body. How hot the body is. We can measure with the quantity temperature. Okay, it is the measure of the degree of hotness or coldness of a body. So, when you take two bodies, okay, we have a ice in one and we have hot water. So, when you keep the thermometers, okay, similar thermometers are kept in this, what happens? You will be able to see that there will be a rise in temperature here. Okay, that is the mercury level will rise. In case of hot water, so here what is happening? There is an increase in temperature happening. Okay, so understood what is temperature? Okay, now why do we need temperature? We have understood what is heat. Why do we need temperature? So when you take a hot body and a cold body, when they are kept close to each other, what happens? The hot body will become less hot and the cold body will become less cold. Okay, so here what is happening? There is a transfer of heat happening. So when there is a transfer of heat, for example, when you take the same case, when you have hot water and ice, okay, they are mixed together or they are kept in contact. What happens? There will be a flow of heat from the hot body to the cold body. Yes, so here the temperature, what happens to hot body? The temperature will go down, which means it becomes less hot. So here the temperature will start rising. It becomes less cold. Coldness is decreasing. Okay, this is what happens. Okay, so one body is giving out heat and the other body is taking heat. Okay, the body which gives out heat will be initially at a higher temperature and the temperature of the body will be decreasing. Okay, and the body which is at lower temperature initially will start receiving heat. Okay, it is a receiver of heat and its temperature start increasing. So when you take a body, we know molecules are there. Okay, when you heat, that is when you supply heat energy, what is happening? We said the temperature is increasing. So here actually what happens is the molecules start vibrating. It gains some energy. Okay, because of this energy, it starts vibrating. Okay, there is random motion. It starts hitting the other particles. Okay, so here this is what happening. Okay, clear? So here if you consider two bodies, this body is at a higher temperature. This is the thermometer mercury level. Okay, here it is. This is the hot body. Now the second body, here that mercury level is in the thermometer. So this is the cold body. When they are kept close, that is they are kept close, what is happening? There is a heat flow. Till when does the heat flow? So when heat flows, this thermometer level decreases here and here it starts increasing. Okay, at an equilibrium state, what happens is the heat had flown from the hot body to a cold body and it reaches a state there is no more heat to transfer. Both the bodies are at the same temperature. Okay, same temperature. So here when you check anywhere, the mercury level will be same. It will be between here and here. Okay, somewhere in between the hot body's initial temperature and cold body's initial temperature. So here you have to understand why do we need temperature. Temperature is to find the direction of heat flow. Okay, to understand the direction of heat flow. So heat flow is always from a body at higher temperature to a body at lower temperature. Okay, so we are able to determine because of the temperature's property, that is it helps us to find the direction of heat flow. Okay. There will be no flow of heat when the two bodies are at same temperature. It is the only case when there won't be any flow of heat. Okay. So, do you think temperature only depends on heat or heat is only dependent on temperature? For example, if you take two bodies, okay, two bodies of different masses. Let's say we have one ice cube and 10 ice cube. Okay. You are supplying same amount of heat to both of this. Okay. After 10 minutes, when you check the temperature, in which case will be the temperature higher? The temperature higher will be in the first case. Okay. Because here the heat energy that we supply is given to only one ice cube. So here that same heat energy supplied is same in both the cases. The heat energy is used by 10 ice cubes. Okay. So to melt, what happens when you supply heat energy to ice cubes? It will start melting when it reaches its melting point, it will start melting. Okay. So this energy is used by 10 ice cubes in this case, but here the heat energy is just used by one ice cube. So one factor on which it depends is mass. Okay. Amount of substance. So amount of heat energy contained by a body depends on its mass. One thing is mass. Okay. Next, if you are supplying the same amount of heat energy to a body at 10 degrees Celsius and 15 degrees Celsius. Okay. After 10 minutes when you check, temperatures will be different. Yes, we are supplying the same heat energy, but their initial temperatures were different. Yes. So the second factor is the temperature. Okay, amount of heat energy depends on the body's temperature and the nature of material of the body. So if you take wood, if you take coal, if you take rubber, if you take different substances, okay. So the temperature, that is the heat energy, when you are supplying heat energy to all these substances, what happens is the way it uses, the temperature change will be different. So these are the three important factors on which the heat energy depends: mass, temperature and the nature of material of the body. Now, the unit of temperature. Unit of temperature is Kelvin, represented by capital K. So, normally we use other unit, that is degree Celsius. So, degree Celsius and degree Fahrenheit are the other units of temperature. Now, what is the relation between them? Okay. So, to find the relation, let's say to convert Kelvin into degree Celsius, what you have to do is, if your temperature given in degree Celsius, let's say 25 degrees Celsius, we need to find how much it is in Kelvin. See, to get this, what you have to do is just add 273, okay, just add 273 with the temperature that is given in degrees Celsius. So, 273 plus 25, that is equal to 298 Kelvin. Okay, so to convert degree Celsius into Kelvin, what you are doing, you are adding 273 to it. Okay, so if you want to convert Kelvin into degree Celsius, what should be done? Okay, temperature is given in Kelvin, you have to convert it into degree Celsius. You have to subtract 273. Okay, subtract 273. Next, what is the relation between degree Celsius and degree Fahrenheit? Okay, so degree Fahrenheit will be equal to 9 by 5 degrees Celsius plus 32. Okay, so this is the relation. So if you want to find, if temperature is given in degree Fahrenheit, this is how you represent degree Fahrenheit, and you want to find the temperature in degree Celsius, what should be done? We will be having 9 by 5 degrees Celsius is equal to degree Fahrenheit minus 32. Okay, so degree Celsius will be equal to 5 by 9 into degree Fahrenheit minus 32. Okay, this is how you can find the temperature in degree Celsius when the temperature in degree Fahrenheit is known. Okay, so understood the conversions? If you have temperature given in Kelvin, you can convert it into degree Celsius or degree Fahrenheit. Okay, so these are the interconversions. The SI unit is Kelvin. Okay, now one more thing, 0 Kelvin. Okay, 0 Kelvin, this is the temperature at which the pressure and volume of a gas, it becomes equal to 0. Okay, so 0 Kelvin, this is known as absolute zero. In the degree Celsius scale, you can have negative temperatures, -2 degrees Celsius, -5 degrees Celsius. These are possible. But when you take the case of a Kelvin scale, there is no negative temperature. Okay, 0 Kelvin is the minimum. So what is 0 Kelvin in degrees Celsius? How to find? To find Kelvin, to convert Kelvin into degrees Celsius, what you have to do? You have to subtract 273. So 0 Kelvin minus 273. You will be getting minus 273 degrees Celsius. Okay, so absolute 0 is 0 Kelvin or minus 273 degrees Celsius. Okay, in Kelvin scale, you won't be having negative temperatures. That is, negative values you won't get. The minimum value is 0 Kelvin. Next is ice point and steam point. So what is ice point? We know that when you take an ice, this ice will get converted into water, and further heating, water will get converted into water vapor. So ice is in the solid state, water is in liquid state, and water vapor is in the gaseous state. So here, for this conversion, we are supplying heat. Okay. And for the reverse, that is water vapor, to convert it into water, we have to decrease the temperature, right? So we are cooling it. On cooling, what happens? The temperature decreases. Then it comes to the state of water. Again, on further cooling, what happens? It comes to the state of ice. Okay, so here you are supplying heat and here you are removing heat. Clear? So we have heard about vaporization, boiling, melting, freezing, all these processes. What is melting? Okay, ice gets converted to water by melting. Ice melts to water. Okay, we have heard about melting point. That is the temperature at which ice starts getting converted into water. This temperature is called the melting point. Okay. Now water to water vapor, there is a boiling point. Okay. At what temperature water starts boiling? So what is a melting point? It is 0 degrees Celsius. 0 degrees Celsius is the melting point. And the boiling point is 100 degrees Celsius. Okay. So when you boil water, okay, when you start heating water, when the temperature becomes 100 degrees Celsius, only then the boiling process will start. Okay, we start the water, it's getting boiled. Clear? Now, similarly is the case of ice point and steam point. So, the ice point is 0 degrees Celsius on the Celsius scale. Okay, 0 degrees Celsius on the Celsius scale. How much is it in the Kelvin scale? For converting degree Celsius into Kelvin, what should be done? You have to add 273. Okay, so 0 degree Celsius plus 273. You get 273 Kelvin. Okay, so 273 Kelvin. Now, what about Fahrenheit? Degree Fahrenheit is equal to 9 by 5 degrees Celsius plus 32. Okay, degree Celsius is 0. So, 9 by 5 into 0, this part gets removed. Then you have 32. So, degree Fahrenheit is equal to 32 degree Fahrenheit in degree Fahrenheit. Okay. So, ice point is 0 degrees Celsius, 32 degree Fahrenheit or 273 Kelvin. Next is a steam point. Steam point is 100 degrees Celsius. So, what is it in Kelvin? It will be 273 plus 100, that is 373 Kelvin. Now, in Fahrenheit. So, to get in Fahrenheit, what should be done? Degree Fahrenheit is equal to 9 by 5 into degree Celsius. So, here the degree Celsius is 100 plus 32. So, cancelling 5, here we get 20. 9 into 2, 18. 18 into 0, that is 180. 180 plus 32. You will be getting 212 degree Fahrenheit. So, the steam point is 100 degrees Celsius, 212 degree Fahrenheit or 373 Kelvin. So, you can see in the degree Celsius and in the Kelvin scale, Celsius scale and Kelvin scale, the difference between the ice point and the steam point is the 100 units difference. Okay. So, here 100 degrees Celsius, 0 degrees Celsius to 100 degrees Celsius. This is the degree Celsius difference is 100 degrees Celsius. When you take the Kelvin scale, 273 Kelvin is the ice point and 373 Kelvin is the steam point. What is the difference here? Here again the difference is 100 Kelvin difference. What about the Fahrenheit? In Fahrenheit, here it is 32 degree Fahrenheit. Here it is 212 degree Fahrenheit. So, in Fahrenheit, there is 180 degree Fahrenheit difference. Okay, in the Fahrenheit scale. Clear? Let us differentiate between heat and temperature. The first point will be the definition of heat and temperature. What is heat? Heat is a form of energy obtained due to the random motion of molecules in a substance. Okay. What about temperature? Temperature is a quantity which tells the thermal state, that is degree of hotness or coldness of the body. And why it is used? It is used to determine the direction of flow of heat on keeping the two bodies at different temperatures in contact. Yes, we have discussed this hot body and cold body. When kept close, what happens? Heat energy starts flowing from the hot body to cold body, which means the temperature of hot body decreases and the temperature of cold body starts increasing. Next, the units. The unit of heat is a form of energy. Therefore, the unit of heat is joules. Okay. What about the unit of SI unit of temperature? The SI unit of temperature is Kelvin, represented by capital letter K. Next, the amount of heat. What are the factors on which it depends? Mass, temperature and the material of the body. Now, when it comes to temperature, the temperature of body depends on the average kinetic energy of its molecules due to the random motion. Okay. So, what happens? The molecules, when you start heating, it gains energy. Because of energy, they starts vibrating. So, this energy is a kinetic energy. Okay, the temperature increase and decrease, it depends on the kinetic energy that is possessed by the molecules due to their random motion. Got 3 points? Now, how do we measure heat? So, heat is measured using the principle of calorimetry, which we'll be discussing in detail. You don't have it in your syllabus now. We'll be discussing in detail in the class 10th. Okay, so understand, heat is measured by the principle of calorimetry. What about temperature? How is temperature measured? We all know, using a thermometer, we can measure the temperature. Next, two bodies having same quantity of heat may differ in their temperature, depending, that is, it depends on the nature of materials. Okay, so if you have two bodies, let's say the quantity of heat, this much joules of heat is present in both the bodies, but their temperature may be different. It depends on the mass of, okay, it depends on not only on the temperature, yes, it depends on the mass, and other factor is the nature of material. So, depending on this, even though say the same amount of heat energy is there, the temperature may be different. Now, when it comes to temperature, two bodies at same temperature may differ in the quantity of heat contained in them. Same thing, because heat, it depends on temperature. Okay, even though the two bodies are at the same temperature, the amount of heat that contains will be different. When two bodies are placed in contact, the total amount of heat is equal to the sum of heat of the individual bodies. This we know. Okay, if you have two bodies at two different temperature, what happens? When you take the sum, okay, the total heat, total amount of heat can be obtained by just taking the sum. If you say, let's say, one body is at 30 degrees Celsius and the other body is at 10 degrees Celsius. Okay, so here the two bodies are at different temperature. But when you take the case of heat, so when you take the case of temperature, you have to find the difference, okay, to get the total amount of the total temperature. But when it comes to the case of heat, it is in joules. Okay, if you take the sum, you will be getting the total amount of heat. Next, when two bodies are at different temperatures are placed in contact, the resultant temperature is a temperature in between the two temperature. Okay, 30 degrees Celsius and 10 degrees Celsius. When you take the difference, you will be getting 20 degrees Celsius. So, approximately in between 10 and 30 can be a value. Okay, the difference in temperature. When you take the average, some value we will be getting for the total temperature. Okay, or the resultant temperature. Next topic is thermal expansion. What is expansion? The increase in size. Okay, in simple words, there is some increase in size. So, that we call it expansion. When you take a rubber band, you pull it from both the sides. What happens? There is a shape change. Okay, the shape is changing. It is expanding. Yes, it is expanding. So, this is what expansion. So, thermal expansion means using the change in temperature or supply of heat energy, there is an expansion happen. Okay, have you ever seen in case of a rail? Okay, in a railway track, when you check, you will be able to see that between some rails, there will be a gap. Okay, there will be some space. So, this is because of thermal expansion to the rail. When thermal expansion happens to the rail, here what happens is during the summer season, the size of the rail, it will start expanding, okay, because of taking in heat energy. Okay, when it expands, there should be some space so that it can come close. Okay, if this is not happening, the rail, it will just it will be congested. Okay, it won't be able to, there will be some
bend sideways.
Okay, so thermal expansion, because of thermal expansion, to prevent this, there will be some space kept in the air. Any substance, it will be solid, liquid or gas, it will start expanding. Okay, when a solid is taken, if you supply heat energy, there is expansion happening because the molecules are gaining energy and it is moving apart. There is random motion happening. Okay, this will cause expansion. Okay. So, in simple words, the expansion of a substance on heating is called the thermal expansion of that substance. Linear expansion, superficial expansion, cubical expansion. So, what are they? So, we will be discussing about the cases of solids, liquids and gases. Liquid, gases. We know that solids have a definite shape. What about liquids? Liquid will be taking the shape of the container in which it is kept. Okay. In case of gas, there is no shape. So, when you take solid, there are three types of expansion possible, which is linear expansion, superficial expansion, cubical expansion. Okay, linear expansion means if you have a rubber band, you cut it at one end and you hold it as a straight line. When you pull it, what is happening? That is the straight line size is increasing. Okay, length of the straight line is increasing. So, initially, let's say the rubber band in your hand. This is the rubber band in your hand. When you hold it here and pull it from one side, what happens? It is expanding. This type of expansion is called a linear expansion. Okay, that is length is increasing. Next, the increase in area is called superficial expansion. Okay, so when you take a rectangular or a square shaped plate, okay, providing some heat, what happens is it is expanding. Let's say it's expanding in all direction, which means its length and breadth, all of these increases, both of these increases. Okay, so the area is increasing, surface area is increasing. This type of expansion is called superficial expansion. Another name is surface expansion. Okay, surface expansion. Okay. So, linear expansion, surface expansion. Now, what will be cubical expansion? That is a complete increase in the volume. Okay, this is called cubical expansion or volume expansion. Okay, now this linear expansion and superficial expansion or surface expansion is possible only in the case of solids. Why? Because they have a definite shape. When you take the case of liquid and gas, they do not have a definite shape. Can you imagine in place of rubber band, you are taking water? Can you imagine linear expansion happening there? No, right? Can you imagine the surface expansion happening? No, right? Only the volume increase will be there. So, volume expansion or cubical expansion is possible in all these cases, but linear expansion and superficial expansion is only with solids because they have a definite shape and other things, that is liquids and gases, do not have a definite shape. Anomalous expansion. So, when does expansion happen? Normally, when heating is done. So, with heating, what happens? Expansion happens. And with cooling, contracts. Okay. But anomalous expansion is when, for example, when you take water. Okay, let's say water which is at room temperature at 27 degrees Celsius. You are cooling this water. What happens? 27 degrees Celsius, when you are cooling, what happens? It will start to contract. Okay. Now, you are further cooling it, the temperature becomes 4 degrees Celsius. So, after 4 degrees Celsius, what happens is the temperature, that is when temperature decreases, further there won't be any contraction. The water molecules, it will start to expand. Okay. Expansion will take place. Okay. That is from 4 degrees Celsius to 0 degrees Celsius, this will happen. Okay. So, here when temperature decreases, when you are cooling, normally contraction should happen. So, this is an anomalous behavior. We are cooling but expansion is happening. So, this type of an expansion is called anomalous expansion. Okay, in a certain range. Here the temperature range is 0 degrees Celsius to 4 degrees Celsius. Okay, during this temperature, that is from 4 degrees Celsius to 0 degrees Celsius, if you are cooling, what happens? Expansion happens. Now, water which is at 0 degrees Celsius, when it is heated to 4 degrees Celsius, the temperature is raised. What will happen? There, expansion should happen normally, but here what happens is contraction will take place. Okay, so this is one substance which undergoes anomalous expansion. So, next is silver iodide. Okay, when you take silver iodide, Here the temperature ranges 80 degrees Celsius to 141 degrees Celsius. During this temperature range, for example, if you are having 141 degrees Celsius, you are cooling it, okay, till it reaches 80 degrees Celsius. During this cooling process, what should happen normally? During cooling, contraction should happen, but here what happens is expansion. That is, in this particular temperature range, expansion happens. So silver iodide is a substance which will be showing anomalous expansion. Next is silica. Okay, with silica, minus 80 degrees Celsius. Below minus 80 degrees Celsius, what happens is, normally when temperature decreases, what should happen? Contraction should happen, but here what happens is expansion. This is also an example of anomalous expansion. So three substances we have which shows anomalous expansion. First one is water in the temperature range 0 degrees Celsius to 4 degrees Celsius. Second is silver iodide in the temperature range 80 degrees Celsius to 141 degrees Celsius. And the third one is silica below minus 80 degrees Celsius. So we can define anomalous expansion, the expansion of a certain substance on cooling in a certain range of temperature is called anomalous expansion of that substance. Okay, now in detail we will be discussing about the anomalous expansion of water. We have said that how is the expansion happening in the range 0 degrees Celsius to 10 degrees Celsius. You will be measuring. Okay, that is you are taking 1 kilogram of water and we are going to find in this temperature range, we are going to find the volume of 1 kilogram of water. Okay, here we have taken 1 kilogram of water. So initially, to change it from 0 degrees Celsius to 10 degrees Celsius, what should be done? We know heating should be done. Okay, only when temperature increases, that is on heating, you can change this. Okay, now initially let's say the temperature is 0 degrees Celsius. So we have taken 1 kilogram of water. Okay, you can see that at 0 degrees Celsius, the volume in centimeter cube is 1000.12. Okay, here it is. Now, what should happen on heating? Normally on heating, there should be expansion. But here what happens? Due to the anomalous behavior, there will be contraction. That is, the volume should decrease. Okay, so you can see at 1 degree Celsius, what is the volume? The volume has changed to 1000.06. Okay, at 2 degrees Celsius, it has again decreased. Volume in centimeter cube has again decreased. It has become 1000.03. Okay, at 3 degrees Celsius, again decreased to 1000.01. At 4 degrees Celsius, the volume has become 1000 centimeter cube. So you can see that at 4 degrees Celsius, the volume is 1000 centimeter cube for 1 kilogram of water. Okay, next what is happening? The temperature is increasing. Okay, further you are heating, temperature is increasing. At 5 degrees Celsius, you can see that it is no more decreasing. Okay, the volume is no more decreasing. Contraction has stopped. Next is expansion. Okay, that is here the volume has become 1000.01. At 6, it has become 1000.03. At 7, it has become 1000.06. At 8, it has become 1000.10. Okay, so you can see there is an increase. Now the temperature, when you are continuously increasing, volume will also be increasing. There is no more contraction happening. That is, expansion will happen. So anomalous behavior is only up to 4 degrees Celsius. Okay, so this is the minimum volume. When you take 1 kilogram of water, for this 1 kilogram of water, the minimum volume will be 1000 centimeter cube. Okay, 1000 centimeter cube will be the minimum volume, and this minimum volume is at a temperature 4 degrees Celsius. So the minimum volume of 1 kilogram of water is at 4 degrees Celsius. Now, if you are having 1 gram of water, okay, if you are having 1 gram of water, in that case again, so here you will be having temperature, here you will be having volume in centimeter cube for 1 gram of water. Okay, so here we had 1000 centimeter cube, 1000.05 centimeter cube, 1000.10 centimeter cube. So here it will be 1.0001 Next 1.0002. This is how it goes. Okay. Here again what happens? When the temperature increases, what happens to the volume? Volume in centimeter cube will decrease initially up to a temperature 4 degrees Celsius and then increases rapidly. Okay. At this 4 degrees Celsius, for 1 gram of water, the volume will be 1 centimeter cube. So, for 1 gram of water, the minimum volume is 1 centimeter cube at a temperature 4 degrees Celsius. For 1 kilogram of water, the minimum volume is 1000 centimeter cube, which is at 4 degrees Celsius. Okay. So, this is a graph which shows the variation of volume in centimeter cube for 1 kilogram of water, or when it is taken in grams for 1 gram of water with temperature taken along the x-axis. Okay, when temperature increases, what is happening? Now, just imagine the opposite when the temperature is decreasing. From 10 degrees Celsius to 4 degrees Celsius, it is normal behavior, that is contraction. Contract means the volume will be decreasing, that is happening. After 4 degrees Celsius, the anomalous behavior starts, that is on further decreasing the temperature, there happens expansion. Okay. So, we have understood the variation of volume of 1 kilogram or 1 gram of water with temperature, okay, with increase or decrease in temperature. Now, let us see the variation of density with temperature. So, here density is given, here the unit is gram per centimeter cube, okay. So, where do you get the minimum volume? Minimum volume we have said it is at 4 degrees Celsius. What is the minimum volume? For 1 gram, if you are taking 1 gram, what is the minimum volume? 1 centimeter cube. 1 centimeter cube is the minimum volume. Okay. We have density. What is density's relation with mass and volume? Density is equal to mass by volume. So, here we have taken 1 gram of water. That is a mass is fixed. Okay. Mass is not changing. For this fixed mass, when volume, normally what is happening in the range 0 degrees Celsius to 4 degrees Celsius, what is happening to volume? That is when you are heating, instead of expansion, here it contracts. That is volume is decreasing. Okay, volume is decreasing. We know that here you can see density and volume are inversely proportional. So, when volume decreases, what should happen to density? Density will increase. Okay, so density will increase. Density increases. Okay, next 4 degrees Celsius to 10 degrees Celsius. Normally what is happening? Expansion is happening, which means the volume is increasing. When volume is increasing, what will happen to density? Volume increases, density will decrease. Okay, density decreases. So, where you are having the minimum volume, there you will be having the maximum density. Yes, what will be the value of maximum density? Here we have density is equal to mass by volume. Mass is fixed, which is 1 gram. What is the minimum volume? Minimum volume is 1 centimeter cube. So, 1 centimeter cube. Okay. So, density, maximum density is at minimum volume, which means here the maximum density will be equal to 1 gram by 1 centimeter cube, which is 1 gram per centimeter cube. Okay, so this is the maximum density. Now, let us see the variation. So, here you can see the graph. Temperature is taken along the x-axis in degrees Celsius, and along the y-axis we have the density in gram per centimeter cube. So, what is happening? From 0 to 4 degrees Celsius. At 4 degrees Celsius, we have the maximum density. Okay, minimum volume, maximum density. Till here, what is happening to density? With increasing temperature, volume is decreasing and density is increasing. Okay, increase in density we can see. Next, further what is happening? The temperature is increased. Okay, when temperature is increased, expansion, volume will increase, therefore inversely proportional to density, therefore density is decreasing. From here on, density is decreasing. Okay, so understood the graph? Here we are taking the density in gram per centimeter cube. Okay. Now, to demonstrate the anomalous behavior of water, an experiment was devised in the year 1805 by the scientist T.C. Hope. So, this is a experimental setup. The experiment was called Hope's experiment, and here first we will understand the Hope's apparatus. Okay. So, first you have a metallic cylinder. Okay. A tall metallic cylinder is there. There are two gaps P and Q at the top and the bottom. Okay. Top P is the gap and Q is the gap at the bottom. Two thermometers are fitted here. This is thermometer T1. Okay, this is thermometer T2 to note the temperatures. Then you are having another cylindrical trough almost at the center of this tall metallic cylinder. Okay, this trough will be filled with a freezing mixture. Okay, freezing mixture which is made up of ice and salt. Ice and salt. So for cooling, this is used. Okay. Now inside the tall cylinder, it is filled with pure water. Okay. Now at regular intervals, the temperature T1 and T2 are noted. This is how the experiment is. Okay. So experiment I will be explaining in detail and what is happening. What are the observation we will be understanding. Hobbes experiments observation. So initially, when we have said that the water which is at room temperature, pure water is filled inside the metallic cylinder. So when you check the temperature, initially you can see that in thermometer T1 and thermometer T2, we will be having the same value. Okay. So initially both the thermometers T1 and T2 shows the same temperature. Next point, first the temperature recorded by lower thermometer T2 starts decreasing and finally it becomes steady at 4 degrees Celsius. Okay. So here this is the setup. Will be explaining why this is happening. So initially when you note in T2, the temperature shown in T2 will start decreasing. At this time in thermometer T1 there won't be any change. Okay, the temperature initially what was noted, the same temperature will be there. In T2 it is decreasing till it reaches 4 degrees Celsius. Once it reaches 4 degrees Celsius, then it is a constant. It is not going to change. Beyond 4 degrees Celsius, it won't be decreasing. Okay, this is happening to the thermometer T2. First, the temperature recorded by lower thermometer T2 starts decreasing and finally it becomes steady at 4 degrees Celsius. While the temperature recorded in upper thermometer T1 remains almost unchanged during this period. Once 4 degrees Celsius is reached, okay, it remains steady at 4 degrees Celsius we have said. Now what happens is the temperature starts changing in the upper thermometer T1. Here the temperature starts decreasing. Okay. Till it reaches 0 degrees Celsius. During this range, there is no change in the temperature shown in the thermometer T2. Okay. In T1, what is happening? The temperature is decreasing up to 0 degrees Celsius. Okay. While the temperature recorded by lower thermometer T2 remains constant at 4 degrees Celsius, the upper thermometer T1 shows a continuous fall in temperature up to 0 degrees Celsius and then it also becomes steady. Okay, understood. So these are the observations which were made. Now we'll understand why this is happening. When you plot a graph for the temperatures given in T1 and T2 versus time in minutes, you will be getting graph like this. First we'll draw for thermometer T1. Okay, first thermometer. So first thermometer is at the top. Okay, this is the first thermometer. Here as we said, what is happening? Let's say the room temperature we are considering is 12 degrees Celsius. Okay, 12 degrees Celsius is the room temperature. Now, we are taking time in minutes along the x-axis and along the y-axis we are having temperature in degrees Celsius. Temperature in degrees Celsius. So, here you will be having 0 degrees Celsius. Here you will have 4 degrees Celsius. Somewhere here you will be having 12 degrees Celsius. So initially what is happening? Initially both are at the room temperature which we have taken 12 degrees Celsius. Okay. So initially you can see that the temperature of T2 is falling. Okay. At that time T1 will remain the same. It will be at 12 degrees Celsius. Okay. Till 4 degrees Celsius is the temperature. The steady temperature is reached in T2. Okay, so till here. So this region we'll call AB. Okay, now at this point what happens? The temperature T1 starts falling. Okay, temperature T1 starts falling till it reaches 0 degrees Celsius. Okay, so this is region BC. Okay, decreases there. Okay, what about the second thermometer T2? Here what is happening? We are taking time in minutes along the x-axis and temperature in degrees Celsius along the y-axis. Here we have 0, here 4 degrees Celsius and here we will be having 12 degrees Celsius. So here what will be happening? What is happening here? Initially they are at room temperature, that is 12 degrees Celsius. Then when the time goes, temperature, what is happening to temperature? Temperature is decreasing until it reaches 4 degrees Celsius. Once it reaches 4 degrees Celsius, there is no further decrease in temperature. Okay, temperature, this is a steady temperature. So this is how the graph is. Okay, this is A, B, C region. Now, actually what is happening here? So because of the stuff which contains a freezing mixture of ice and salt, what happens in the central region, the water in the central region, it starts cooling. Okay, normally it is at 12 degrees Celsius, it starts cooling. Okay, cooling means what that is? Here temperature is decreasing. When temperature decreases, what happens? Contracts, water contracts. Okay, water contracts means what happens to density? Density increases. Okay, density increases. Till where? Till the temperature becomes 4 degrees Celsius. Okay, till the temperature becomes 4 degrees Celsius, the density will increase. There is contraction. Okay, now water, here when you compare in the lower region and the central region, you can see that here the density is more. So density is more, denser part will go down. Okay, so this water will start coming down. Okay, so this happens until, this continues until all the water below the central portion reaches a temperature of 4 degrees Celsius. This is why in the thermometer we will be seeing 4 degrees Celsius. Before reaching 4 degrees Celsius, the temperature is gradually decreasing and once it reaches 4 degrees Celsius, there is no further change in the temperature. It will be the same. Okay. After 4 degrees Celsius, what happens? We know the anomalous behavior of water. After 4 degrees Celsius, what happens? On further decreasing the temperature decrease. Okay, what happens? There is expansion. There is expansion. So the water which is in the central portion will now start expanding. Expanding means what is happening to density? Density will decrease. So the density of water in the central portion has now decreased. So decreased means less denser part will rise up. Okay, it will rise up. Less denser part will start rising up, which means the water here will start coming down. Okay, so here temperature is decreasing. So temperature is decreasing till where? Till 0 degrees Celsius this can happen. So now here it is 4 degrees Celsius. There is not going to be any change because we know that the maximum density is at 4 degrees Celsius. Okay, maximum density once obtained at 4 degrees Celsius, there won't be any change. So here it has rise. Now this water, it will start forming ice. Okay, so when you note the temperature, it will be 0 degrees Celsius. So we know that at 0 degrees Celsius, what will be happening? Below 0 degrees Celsius, it cannot go. Okay, it will reach 0 degrees Celsius and start forming ice. Clear? So this is what's happening inside a Hobbs apparatus. Understood? Okay. Consequences of anomalous expansion during the winter climate or during the cold season, what is happening? We know that the atmospheric temperature is decreasing. Atmospheric temperature may go below 0 degrees Celsius. So, in any water bodies, okay, lakes or rivers, there will be a topmost layer of water. Okay, so this layer, during this, when the atmospheric temperature is decreasing, this layer will start radiating heat energy. When it radiates heat energy, here you can see the temperature is decreasing. Okay. Till 4 degrees Celsius, what is happening? Till 4 degrees Celsius, when the temperature decreases, there will be contraction. So this layer of water, it will radiate heat energy. It will start turning cooler. Okay, which means it is contracting. The density is increasing. So when the density increases, what happens? The high density water, it will go to the lower layers. Okay, it will start going to the lower layer. Okay, that is till the entire water. Okay, entire water which is below this layer becomes 4 degrees Celsius. Okay, so when the temperature goes below 4 degrees Celsius, what happens? Below 4 degrees Celsius, there is anomalous expansion of water. So no more contraction will be happening. Okay, that is for the surface layer. Okay, for the surface layer, when the temperature is below 4 degrees Celsius, here expansion will start. Okay, expansion means the density, what is happening? The volume is increasing, the density is, what is happening to the density? The density is decreasing. Okay, density decreases means it won't go to the lower layers. It will stay here itself. Okay, once it reaches, as temperature reaches 0 degrees Celsius, what happens? 0 degrees Celsius, once it's reached, it will start turning into ice. That is, the water freezes to become ice. Okay, so here a layer of ice will be formed. This layer you can see, a layer of ice is formed. Okay, at 0 degrees Celsius. So just below this we will be having water which is at 0 degrees Celsius. Now, what about the case of ice? Ice is a poor conductor of heat. Okay, ice is a poor conductor of heat, which means the heat energy that is inside cannot go outside from now on. Okay, it cannot be radiated outside because it does not allow, the ice being a poor conductor of heat, it does not allow the heat to escape. Okay, so here below, in the below layers, in the water, there will be some water bodies. Okay, there will be aquatic life. In these water bodies, there will be aquatic life, fishes, aquatic plants, etc. So these life, in these aquatic life will be preserved. Why? Because if all of this water turns into ice, then the aquatic lives will get freezed. Okay, and they will die. But here what is happening? Only the top layer we have ice. Okay. To the bottom layers, you can see the temperature is 0 degrees Celsius, here 1 degree Celsius, 2 degrees Celsius, 3 degrees Celsius, 4 degrees Celsius. Okay, that is a higher temperature is there, which does not allow the lives to freeze. That is, the water does not freeze and it will prevent the death of these organisms. So, here this is what happening. Okay, a layer of ice is formed. This layer of ice protects the aquatic lives. Okay, the anomalous expansion of water helps in preserving aquatic life during very cold weather. Okay, understood this? Second is, the anomalous expansion is responsible for bursting of water pipelines and destruction of crop during very cold night. So, during the very cold night, what is happening? The temperature is going below 4 degrees Celsius. Below 4 degrees Celsius, what will happen? There is anomalous expansion. So, expansion will happen. That is, volume is increasing. Yes, volume is increasing, which means these water inside the pipeline, they will start exerting more pressure on the walls of the pipes. Okay, so due to this pressure, what happens? The pipeline will start to burst. Okay, now in case of plants, what is happening? In plants, we know the transportation of water is there. Okay, in capillaries, there will be water. So in these capillaries, which are in the like a tubes, here, when the temperature goes below 4 degree, atmospheric temperature goes below 4 degrees Celsius at night, what happens? Here, the waters in these capillaries, because of the decrease in temperature, they show anomalous expansion. The water will start expanding. They need space to expand. Okay, here there is no space. So, they start exerting pressure on the walls of the capillaries and finally, it will burst and destroy the plants. Okay, so this is what happens. Now, in case of crops also the same thing is happening. So, to prevent this, what can be done is, you have to spray water on the land. Okay, on the fields you have to spray water. So, if you do that, what happens is, because of the decrease in temperature, the water will also start getting cooled. It is not, that is, all the pressure is not only on the capillaries. Here, the first the water will start to cool, which you are spraying. Okay. So, the plants and the crops can be protected. That's all for today. In today's class, we have discussed about heat and temperature, their units and the difference between heat and temperature. We have also explained about the anomalous expansion of water and their consequences. Hope you all enjoyed the session. I'll be back in the next session. Until then, stay tuned to Learnohub. Learnohub free hai, par best hai. Thank you.